My name is Professor Abbas Al-Muallim. I'm the head of the discipline of construction and project management at the School of Natural and Built Environment at the University of South Australia. I'm very excited to be leading this interdisciplinary project about advancing industrialized and prefabricated construction and approach to future economies. The construction industry is one of the main contributors to the Australian national economy, with contribution about 10% of the gross domestic product. The industry is also, however, being criticized for lack of innovation, low productivity, and the huge amount of waste within the processes. To address these challenges facing the construction industry, we believe the concept of the circular economy is rapidly evolving, and the construction industry is well positioned to leverage its potential to tackle climate change and creating future economies. The aim of this project is to carry out the technical groundwork needed for the establishing of centralized facilities for testing and development of prefabrication in South Australia in collaboration with our partner APC.
I'm pretty excited that we're actually having this workshop because we've planned it several times, and actually it is good, very good timing. A few things have happened that are worth reporting. So basically this is a workshop connected with a project grant that Abbas and others applied for under the title Advanced Industrialised and Prefabricated Construction, an approach to building future economies. That's the overall title, and we are going to focus in the first couple of presentations on a sub-project of this project, which is about the making of magnesium oxide board, which is truly fire resistant and also made entirely out of Australian materials. And there's been a very nice interaction, in my view anyway, between APC, Australian Portable Camps, and the university in relation to some of the technical issues of proving this board. So the first thing I want to do is just get people to introduce themselves, and we might start here with Sharif. Just say, I think Robert would like you to stand up, is that right? Stand up and just say who you are. And yeah.
Good morning everyone, my name is Sharif Mustafa and I'm the research associate for this project.
Yep, go ahead.
Hi, my name is Tim McGinley. I'm over in Architecture Department, and thanks for inviting me. Pleased to be here.
Good.
Simon Beecham, Pro-Vice Chancellor for the Division of ITE, and I'd just like to say how pleased the division is that first of all we're engaged in such a strong partnership with APC, but secondly that also we're doing such interesting and innovative interdisciplinary work. So I'm very much looking forward to this. So thank you.
Thanks. Julie.
Julie Mills, head of the School of Natural and Built Environment.
Hello everybody, I'm Reza Hassanli. I'm a lecturer here and I've just finished my PhD 6 months ago. Yeah, thank you guys.
Morning everybody, my name is Shima. I'm a senior lecturer in engineering.
Hello everybody, my name is Said. I'm a construction engineering and I'm doing some testing lab for any department or something related to construction engineering.
Michelle.
Good morning everyone, I'm Michelle Flynn, working for the School of MBE as Quality Manager with the construction materials and mechanical testing.
Abbas Al-Muallim, I'm Professor in Construction and Project Management, and I'm excited and delighted to be part of this interdisciplinary project with APC.
Hello everyone, my name is Sebastian Hebert. I'm the Business Development Manager for the Division of Prefabrication.
Good morning everyone, my name is Nicholas Chalaisha and I'm a senior lecturer in construction and project management at the University of the Natural and Built Environment. Thank you.
Good morning, my name is Ken Bodie, I work for APC. I've been heavily involved along with Peter here in the production and development of this magnesium oxide board and the relevant processes around it.
Morning all, Peter Bodie, I'm virtually coordinator between APC and the uni, thanks to the support of Dennis and Abbas.
My name is Frank Martino. I'm a chef by trade. but I always loved innovation, always loved new things. Many years ago, I was challenged by a big multinational company when we had to relocate a camp. They told me I did not know what I was talking about. So I said, all right, I will show you. So after the project finished, I sold my real estate property in Adelaide, and I started building. Without design, without plans, without engineering, without contract. We haven't stopped building. We got 12,000 buildings all over Australia at present because it was an idea. I've been always believe in idea, in new way to do things, to do it smarter, to do it more efficiently, and to do more economically. We're doing a lot of other research, and I'm very thankful and I'm very blessed to have Peter and his son Ken with me, that they're helping me, they're driving me to all this R&D, because I had the idea to produce here in Australia MGO board, because the only place that it is produced at present it is in China. They not always constant, and even Australian company, international company like Promet, which they got their own company in China. Promet is a multinational. It is the biggest company in the world with the fire. Whenever come to fire, all products with the Promet, they are the best and the most expensive in the world. And we bought board from Promet. They filed. They all filed, with the fire and with other things, they filed. So I said, well, if I have to produce board, panel board for housing, which that is how and why I need all this MGO board, I said, I cannot afford it, that if they file, I will be sued. So that is when I started to look to produce my own MGO board. And then, luckily, Peter walked through the door after 35 years, walked through the door, and I said, well, I need you. And here we are. So, but first of all, not only to Peter, I want to say thank you to all of you, because you put a lot of effort, you put a lot guidance, and money also to help us get there. But I can assure you one thing, this is a product that all the world will use it. This has been used in the turn of last century in America, and it failed because the magnesium, they were not able to control the magnesium chloride, because magnesium chloride corrode things. And then there are other problems with some infill that they put in that was giving some type of smell. And in New York, there've been quite few court cases, mass action, class action against that thing. So that hasn't taken on. Then the Chinese, they revived the thing. And they done quite a reasonable job, except they haven't really quite mastered everything. But we get every day people interested, keen to buy this product. They want to use this product. So I believe with your help, we're going to have something that nobody has got in the world. We're going to have a world first product that will be used and will be mass produced anyway. So I want to say thank you to all of you. Thank you.
When you're producing 2 trolley loads of a board, the whole area gets very quickly totally that you can't move there. You've got so many trolleys with boards drying. So we're looking at different ways of curing the board. One is to gradually ramp up the temperature, and another one is to have 2 zones, one at a set temperature and then one at a higher temperature, but you've got to control the curing. And again, we do all of the analysis here on the SEM QXRD, and we do the result interpretation on these small samples.
We have a full-size plant set up. We have a pilot plant, which is a smaller version, and we have a full-size plant set up for full production, which is approximately 2,000 boards a day. Each trolley will take about 15 boards, so you can do the maths from there as to how long it takes to fill in, etc., etc. I've got a video to show you very quickly. It's an indicative idea of what the process involves. Okay, it's not exactly what we do. We're not allowed to take footage of what we do on site due to obviously commercial and confidence issues. So I'll just walk you through this very quickly. So obviously you've got the board stacker. So these are the form boards or plenums. This is what the mag oxide board gets made on. They're moved onto the line automatically. You try and make these processes as autonomous as possible, but I'll get into that a bit later on. Runs down the line. This particular part of it here is where you put your mould release agent on there. So that acts to go between the mag oxide board and the plenum itself, which allows you to take the board off once it's been cured and dried. Okay? So I'll let this process run through for a little while. I'll explain the most pertinent parts of it as we're going. Yeah, feather dust are very important. Spanner and funnel. We don't have any of that, obviously, but I thought it was interesting. So there's some fibre reinforcing netting being put into the layer of the board as it comes across, and the next stage will obviously be your magnesium oxide that goes onto it, or your magnesium oxychloride mix that we produce that goes onto the actual line itself, and that is what creates your board. So at the moment we've got a fiberglass reinforcing netting in it, and then you'll come to this stage once we get past all this stuff, where there it is there. Okay, so that's your reservoir, if you will. You've got another form of netting which goes in over the top of it. So at the moment we've created a plenum board, a form board, we have a face netting, we have our mix going on, and then we have another structural netting layer on top of that. And that's your fundamental mix of an actual board that's been manufactured on the production line as opposed to what we do in the laboratory. So we have our mix ratio for that particular run. We then get onto our pilot plant, we set it all up, and we run our pilot plant. Typically we do about 100 kilograms of mix. To give you an idea, on a big plant like our large full-scale production plant, you're looking at about 1.8 cubic metres of mix per run, which is, from a tonnage point of view, a hell of a lot more than 100 kilos. So we do a small mix in the laboratory, about 100 kilos on the pilot plant, and then full-scale production is an awful lot. All right, so it gives you an idea of how we scale things up as we're moving. One of the things that has become very apparent during our research and development stages is the curing times and curing of the boards. As I'll get into a little bit later on with the SEM analysis, as the boards cure, the ability for the board to continue producing the magnesium oxychloride, which provides an awful lot of structure within the board. Not only have you got the fiberglass reinforcement, but you've also got the oxychloride in there that's actually forming the cementitious element of the board. Without that cement, you're not creating anything, you're just creating wheat bix, and that's no good to anyone.
And we have one professional affiliation, which is Prefab Oz. Their aim by 2020 to enhance this 3% to be 10% in the future. We identified the main drivers and barriers of prefabrication. Normally the drivers always associated with the completion time, reduce the completion time, have most of the work to be done in a controlled environment in the fabrication facility. So this somehow will ensure the high quality of the components. Some of the barriers, which is, I would just mention one of the main barriers, which is the lack of financial support, which is somehow the banking organization in Australia, they look at the prefabrication as kind of like risky project, and they always avoid to give mortgage for most of the household to go for this kind of prefabrication houses. The last one, which is sustainable aspects of prefabrication, we try to relate the prefabrication with the 3 dimensions of sustainability, the social, environmental, and economical. Later on, we moved to the site visits. We done some site visits, and from these site visits, we identify what testing needs and also the kind of certification of the processes and the material used for the prefabrication. The building system they use, is it the panel system, is it module system, all these things, digital technology and how digital technology can be integrated within the whole life cycle of prefab project, from the concept development, moving to the design, engineering, fabrication, the site work, and finishing and hand over the project to the client. The second also, which is sustainability integration, what kind of sustainability they use. Is it mainly for the environmental, or they have some economic and also social aspects? We did some meetings with our project team experts, and from this meeting we identified that the need for new testing methods and having Australia-wide certification. I think Ken mentioned about many guidelines on many certifications. So if there is one Australia-wide certification, this can be one of the needs for the business to pursue and to uptake more. The last point from the meeting with the experts, intellectual property, the IP of materials. We get to know from the APC they invest a lot of money in their pilot plant in order to just come up with new materials. So to protect this identity of this kind of material, this is also one of the needs required.